Well, we're back here at the Cave of Science, and we're looking at wave speed, especially as it pertains to the speed of light. We know wave speed equals frequency times wavelength. Covered that in class, where wavelength is going to be in meters. Frequency is the number of wavelengths that pass a given point per second, or another term for that is cycles, and that's 1 over s. And then wave speed is going to be in meters per second. So that's the overall general formula. Now, if we're looking at an electromagnetic wave, which most of our work is going to be done, the formula is the same, but it does change a little bit. C equals frequency times wavelength, where C is the speed of light. And the speed of light in a vacuum is going to be 3 times 10 to the 8th meters per second. So if you have any problem where you're working with the electromagnetic spectrum, you're to assume the speed of light is 3 times 10 to the 8th meters per second. Now, if we want to take this formula, and I'll rewrite it here, frequency times wavelength, and let's say we want to solve it for frequency. So we divide each side by wavelength. Well, wavelength cancels out, so frequency equals the speed of light divided by wavelength. Likewise, and I'll just write it over here, let's see, speed of light equals frequency times wavelength. If we want to know what the wavelength is, we divide each side by frequency. Frequency cancels out, so wavelength equals the speed of light divided by frequency. So really, that's all we're working with in this particular section of this unit. Now, the base formula, wave speed equals frequency times wavelength, and then we can calculate the other two variables if needed. All right, I'm going to do a couple problems from the worksheet, and they're pretty indicative of any of the problems that you can do. So I'm going to turn this over. Now let's get the worksheet problem out. Yeah, let's do problem number 4. Oops, let me get rid of this. And let's do problem number 4. Calculate the frequency of yellow light with a wavelength of 580 times 10 to the minus 9th meters. Well, again, you're talking light, so you're talking electromagnetic spectrum. So we know C equals frequency times wavelength. We know the speed of light. We know C equals 3 times 10 to the 8th meters per second. We had to calculate frequency, so we don't know what that is. And we've got a wavelength of 580 times 10 to the minus 9th meters. So we can plug this into our formula. C equals 3 times 10 to the 8th. We don't know frequency, and we do know wavelength. I want to put this in parentheses. So 580 times 10 to the minus 9th. So to find frequency, we've got to get rid of this number, so we divide each side by this number. So 580 times 10 to the minus 9th, 580 times 10 to the minus 9th. So we know that cancels out. So now we have frequency equals this value. So now we can take our calculator, and I'm going to put it right here. See if I can get it right here next to it. So we got 3, and again, I like to use the EE button. and that's 3 times 10 to the 8th. And again, that E stands for times 10. That's going to the exponent. And we are dividing by, and just write the number as it is, 580. And that's another exponential form, 580. So we have EE, and it's to the minus 9th. So that's a pretty small wavelength. So minus 9. And you can see I used this, let's see. I use this button down here to make that a minus 9. And then I hit enter. And my answer comes out to be, and I'm just going to round it up, 5.2 times 10 to the 14th. And again, frequency is measured in hertz. So very straightforward problem. Again, we have 3 variables. You have to have 2 of them to do the calculations there. Alright, let me clear this one. And let's look at problem number 5. And let's see, I think I'll flip this around. Let me get a new piece of paper. Might work a little nicer. Calculate the wavelength of red light with a frequency of 460 times 10 to the 12th hertz. So again, we're looking at light, so we know that's the electromagnetic spectrum. So C equals frequency times wavelength. We know C is 3 times 10 to the 8th meters per second. Calculate the wavelength, so we don't know what wavelength is, and we do know what frequency is. And again, just write down the number. 460 times 10 to the 12th hertz. Alright, we can substitute these numbers in our formula here. So C, 3 times 10 to the 8th. Yeah, I'm not going to put the units in this particular spot. We know frequency is 460 times 10 to the 12th. And we're looking for wavelength. We'd probably assume a pretty small wavelength here, just because frequency is a pretty big number. Well, if we want to get wavelength by itself, got to divide each side by 460 times 10 to the 12th. Divide this side by 460 times 10 to the 12th. Again, this is going to cancel out. So wavelength is going to equal 3 times 10 to the 8th divided by 460 times 10 to the 12th. And I'm going to shove this up a little bit. So we want to find out what wavelength is. Well, again, we can use our calculator on this. And again, I like to use the leave it right in exponents. So we got 3 second EE, and that gets us our exponential form, to the 8th divided by 460 second EE, and that is to the 12th. And we can hit enter, and as we expected, it's a pretty small number. And I'm just going to round it up. 6.5 times 10 to the minus 7th, and that's going to be in meters because that is in wavelength. So that's another, it's really the same formula. We're just moving things around a little bit. Alright, let's do another one on here. I'm going to do one more of each. Let's see if I can move this up a little bit. And let's look at number 11. Ultraviolet rays that cause sunburn are called UVB rays. They have a wavelength of approximately 300 nanometers, and they really tell you what it is here. 3 times 10 to the minus 7th meters. We want to know the frequency. So again, ultraviolet light, that is going to be an EM spectrum problem. So we know wave speed, or the speed of light, equals frequency times wavelength. We know c is 3 times 10 to the 8th meters per second. We don't know the frequency. We want to know what the frequency is. And we know wavelength is 3.0 times 10 to the minus 7th meters. So again, let's go back to our formula and substitute in. C is 3 times 10 to the 8th. Frequency we don't know, but we do know wavelength. 3.0 times 10 to the minus 7th. And I'm going to put this in parentheses. So again, it's kind of the same problem that we did before. If I want frequency, I got to divide each side by the wavelength. So 3.0 times 10 to the minus 7th. 3.0 times 10 to the minus 7th. This cancels out. So frequency is going to be 3 times 10 to the 8th divided by 3 times 10 to the minus 7th. Let me push this up a little bit. Let's go ahead and get our calculator out. So we got 3 second EE. And again, that gets you to the exponent, to the 8th. And we are dividing by 3 second EE to the minus, and again, got to change the sign down here, minus 7. And we hit enter, and it's F equals 1 times 10 to the 15th, and frequency is in hertz. Again, really a pretty simple problem. It's just a straight division problem there. All right, so let's look at one more here. Let me flip this over, and let's look at number 12. And again, all these problems really work off the same basic idea. Infrared rays from the sun are what make our skin feel warm on a sunny day. If an infrared wave has a frequency of 3 times 10 to the 12th hertz, what is its wavelength? So C equals frequency times wavelength. It's another EM problem, so C is 3 times 10 to the 8th meters per second. Let's see, infrared, we want to know the wavelength, so we've got frequency is 3 times 10 to the 12th hertz, but we don't know the wavelength. So we got to calculate the wavelength. So again, let's substitute in. 3 times 10 to the 8th equals, frequency is 3 times 10 to the 12th, and we don't know a wavelength. Same problem. If we want to find wavelength, we got to divide each side by 3 times 10 to the 12th. So 3 times 10 to the 12th. Divide each side by 3 times 10 to the 12th. This is going to cancel out. So wavelength equals 3 times 10 to the 8th divided by 3 times 10 to the 12th. Well, we can go ahead and use our calculator again. Let me turn it on. And we got 3 to the 8th divided by 3 second EE. Oh, I think I screwed up. Let's go back and do that. So we go 3 second EE to the 8th divided by 3 second EE to the 12th. And we get 1 times 10 to the minus 4th, and we're looking at meters, and that is our wavelength. So again, all these problems really work the same anytime you work with an electromagnetic spectrum. Just for instance, if I have wave speed equals frequency times wavelength,